Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to electricity and magnetism, and so far we have covered uh, the questions and answers, problems and solutions, that part related to first Coulomb's law related to electric charge, then about superposition principle also related to electric charge and Coulomb's law, multiple electric charges. So in this video we are going to solve some questions related to electric field, concept of electric field. So the next series of videos will be on that. So here is the first question. The question is that two horizontal plates which are separated 10 millimeter apart, they have a potential difference of 1000 volt between them. Okay, they are connected to a source of electric potential, and a potential difference of 1000 volt is maintained in between them. The upper plate is at positive potential, it is positive. If a negatively charged oil drop of mass 4.8 into 10 to the power minus 15 kg is held stationary between the two plates, find the number of electrons in the drop. And the data which is given is that we have to consider acceleration due to gravity small g as 10 meter per second square, and the electronic charge, whether it is positive or negative, whatever we are considering, that value, that magnitude is 1.6 into 10 to the power minus 19 coulomb. This is the information that is given. So first we have to draw the diagram with respect to the data or information which is given. That is the first step. So two horizontal plates there are. So let us draw them. Let's say this is the first horizontal plate, and then this is the second horizontal plate. Distance between them is 10 millimeter. This, okay, this is the separation. Other data which is given is that they are connected to a source of electric potential. So let's say this is connected to a positive potential, the positive terminal, and this is connected to a negative terminal, because the upper plate is at positive potential, it is given. Okay, so this is positive, this is negative, and the potential difference is 1000 volt. We have already discussed about electric potential also, okay, potential difference, electric potential, but this question is related to electric field, but the concept of potential has come, so we'll see how we'll solve this. Okay, this is 1000 volt because it is connected to a source of potential difference of value 1000 volt. Then it is given that we have a oil drop, a negatively charged oil drop. Yes, negatively charged oil drop. Okay, so we have a drop negatively charged which is held stationary in between these two plates. That is, no motion, no movement up and down or sidewise, no movement of this oil drop. It is totally stationary. Stationary means that the net force acting on this oil drop, okay, this oil drop, the net force acting on it is zero. Only then it can be stationary. Stationary means net force is zero. So the two forces acting on it will be, first, the force due to the electric field, okay, it will be in the upward direction. Because it is negatively charged, it will try to move upwards towards the positive plate. So that value will be the total charge that is contained in the drop. Let's say it is Q, small q we are taking, and the value of the electric field. We know electric field is equal to the Coulombic force divided by unit test charge value. Basically, simply speaking, electric field is force by charge. So F will be simply Q E vector. We have already discussed it. Okay. So this will be the electric force acting on it, and then because of the mass of the drop, there will be a downward force acting on it, which is the gravity force mg, where the mass is this much, 4.8 into 10 to the power minus 15 kg, mass of the oil drop. Okay. So as this oil drop is stationary, it means net force is 0, which means the electric force and the gravity force, they exactly balance each other out. They are equal in magnitude, opposite in direction. Okay, they are equal in magnitude, opposite in direction. Now we have been given the value of electric potential, which is 1000 volt. We have to determine the value of electric field. Now electric field is basically V by the separation distance, the gap. Here L is equal to 10 millimeter, which is equal to 10 into 10 to the power minus 3 meters. So we'll simply put here 1000 volt by 10 into 10 to the power minus 3 meters. Okay, this much. So it will become 10 to the power 5 volt per meter, the value of electric field. That is the value of electric field. We have been asked to find the number of electrons. So here this charge, the total charge, Q is the total charge contained in the oil drop, the negatively charged oil drop. So Q, we have to find this Q, that will be equal to mg by E, mg by E. So here m is equal to 4.8 into 10 to the power minus 15 kg, g is equal to 10 meter per second square. We have been asked to take the value of g as 10, not 9.8. So whenever data is specified to take this value specifically, always use that value. Don't use 9.8 here, otherwise the answer will come wrong. And then by E, which is equal to 10 to the power 5. All are in SI units, so everything is correct. So now we will calculate it. I'll be using a calculator. So no need to use a calculator also. It's simple. 4.8. This will go minus 10 to the minus 20 into 10. That will be 4.8 into 10 to the power minus 19. Okay, this much coulombs. That is the total charge. This is the total charge in the drop. Now we have been asked to find the number of electrons. Now we know one electron, it contributes 1.6 into 10 to the power minus 19 coulomb. Okay, one electron, that is one negative charge. Okay, negative charge. So here, to find the number of electrons, what we'll simply do, we will first take the total charge by charge on one electron. Okay, the charge contained in one electron, that is total charge in the oil drop divided by electronic charge, 1 electron charge. So it's basically 4.8 into 10 to the power minus 19 coulomb divided by 1.6 into 10 to the power minus 19 coulomb. This will get cancelled, this will be 3, the value will be 3. So there are a total of 3 electrons in the oil drop. The oil drop contains 3 electrons. So the number of electrons in the oil drop, that is equal to 3. This. Okay, very simple. Here the concept of electric potential came, but you have to remember electric potential is equal to, we know potential difference as line integration of an electric field, electrostatic field that we derived. So simply if we reverse it, if we take from LHS to RHS simply, then electric field is equal to electric potential divided by the length or the distance, the gap separation. So that we determined first the value of electric field, the magnitude. Then it was given that the oil drop is stationary, so the net force acting on it is 0. We balanced both the electric force and the gravity force, the two forces acting on this charged oil drop. Then we determined the value of the total charge contained in the oil drop, small q, which is we calculated as 4.8 10 to the power minus 19 coulomb. Then we know 1 electron, it carries 1.6 into 10 to the power minus 19 coulomb of negative charge. Number of electrons which are present in that oil drop is equal to 3. So here this value will always come in the form of an integer, because we know charge is quantized. Okay, q will always exist in the form, the total charge will always exist in the form of q is equal to NE. So this n will always be an integer. So yes, the value came as 3. Okay, so this is the first question related to electric field.